The root mean squared velocity of bromine gas at room temperature can be calculated at around 200 meters per second. Lonnie can demonstrate that by allowing bromine gas to race down this raceway that he's produced. First, he'll fill one end of the flask with gaseous bromine, open a valve, and let it race to the other end of the flask. Here's one flask filled with bromine. Now watch carefully, this will happen fast as he opens up the valve and bromine races to the other flask. At 200 meters per second.
I finally found a video that confirms exactly what I was thinking for a while now. Rockets don't work in a vacuum. There's nothing for a rocket to propel off if it's devoid of particles in a vacuum. As you can see here, the rocket only begins to move when the gases physically push off the chamber, the vacuum chamber. If rockets really had thrust in a vacuum, this rocket should have immediately started moving the second the gases came out of it. But it only started to move the second the gas started to equalize inside the vacuum chamber and push off the walls of the vacuum chamber and cause it to move. There are no physical walls in space.
Okay, so thrust is possible in a vacuum. Y'all have proven that. My thing is, how is this accurate? Because the vacuum chamber is way out of scale. See, space is like billions of times bigger than the rockets that y'all shoot. Okay? And in this video, as you can see, once the thrust go off, it's no longer a vacuum chamber. And they even admitted that they had to seal off part of the igniter in order to leave atmospheric pressure just for them to light the fucking rocket. So my thing is, once that rocket's lit and that atmospheric pressure is left into the air, as you can see, majority of the flame ignites in the chamber, not even at the end of the rocket. And that's because they have to release atmospheric pressure into the chamber. Now look, this is one of their previous attempts. And as you can see, nothing happened. The igniter could not even light the rocket and immediately goes out.
That is the problem that we're having all along.
Look, that is the problem.
What do you think, Mike? We can repack an igniter and try it again.
We can try it again.
Looks like we may need some atmospheric pressure.
We may need some atmospheric pressure
to get it to ignite. Once it's ignited, I think it's going to do okay. What do you think, Mike?
We'll try it again. It could be from the lack of air, from the type of igniter.
Lack of air.
The cap being on it. Hard to say.
The fact that the cap's on it.
Lit in a vacuum, it's going to stay lit.
It should, yeah. It's got its own oxidizer.
Let's see what it looks like.
Yes.
Okay, so how is it the case that we have atmosphere on Earth without a solid container?
Because it's attracted to the Earth.
Via gravity,
Via
right?
gravity.
But why doesn't gravity hold the air in the shoebox?
Because the shoe doesn't have enough gravity.
The Earth presumably does.
Earth has a lot of gravity.
The Earth is inside.
And the shoe doesn't.
So why doesn't Earth's gravity hold the air inside the box?
Because, sorry,
why doesn't Earth's gravity hold the air inside of the shoebox, which is in the midst of the vacuum?
because the gas has pressure. So it has pressure and it
just goes out into the vacuum.
Sorry,
I'm just saying.
I have people waiting and I need to go.
A little feather right there, as you can see, suspended in front of a 12-volt electric fan. See, I got the batteries, a pressure gauge, and everything in there. To turn it on, I have a little tilt switch that is magnetically controlled. You can see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. So, I want to take this down to Martian conditions. You might have noticed the Martian reference over there. The first thing I'm going to do is add a little bit of dry ice to the chamber, just so that the atmosphere gets replaced with CO2. Many of you guys were complaining about that last time. So now I should have a CO2 atmosphere, or at least it'll create one. And now we're going to suck out all of the air, at least most of it, down to the point where about between 4 to 6 millimeters of mercury, which is, of course, the pressure on the surface of Mars. So let's plug in the vacuum pump. There we go. Give this a little while to suck down. These pieces of CO2 look really interesting in the vacuum. The gas produced causes them to levitate and float all over the place. But if you can see the gauge over there, you can see that the air pressure is just about to the point where it would be considered the surface of Mars. So since we're at Martian air pressure, let's unplug the vacuum pump and let's turn on this fan. Now place your bets as to what's going to happen to this feather. Now the fan's only going to produce maybe 10 miles per hour worth of wind. On the surface of Mars, the fastest recorded wind speed is about 70 miles an hour. But let's say the superstorm in the Martian had wind speeds of 200 miles an hour, 20 times what we have here. To compensate for that, I imagine the feather is about 20 times easier to push over than a spaceship. So let's see what happens. Okay, fan's on. And the feather's not moving. In fact, let's zoom in on that.
This second experiment proves that combustion is not possible in a vacuum.
So how about something that has its own oxidizer, such as gunpowder? See, this is a mixture of charcoal, sulfur, and potassium nitrate. When heated, the potassium nitrate gives off oxygen, which the sulfur and charcoal uses to burn. So I've got a little bit sitting in there. Let's apply the laser goggles, and let's light it off. First in the atmosphere, and then in the vacuum. Okay, as you can see, it produced lots of smoke and burned rather quickly. Most of the air is now gone. Let's see what happens. The gunpowder did not ignite. And that's it. The gunpowder does not burn. And so I'm going to be burning some rocket candy. This is a mixture of sugar, potassium nitrate, and iron oxide. This is used in amateur rockets because the ingredients are readily available and the amount of thrust it produces is quite high. So let's light this on fire and see how it does. So this is in Earth atmosphere. Moved it around. So now let's try it inside of a vacuum. No ignition. That's interesting. I did see some little poofs as it tried to burn, but it was unable to sustain itself. So even when it's in one solid piece, they can't chain and continue burning. Acetone peroxide in the atmosphere in 3, 2, 1. Yes, that's a little bit more volatile than gunpowder is. Acetone peroxide in vacuum in 3, 2, 1. It still didn't burn.
So essentially, what we have here is solid evidence that space travel is fake. Therefore, the Mars rover is a complete hoax, and this Mars simulated environment on Devon Island is where they fake Mars rover footage, and where they will fake all future Mars footage. I mean, they could fake this anywhere really, Greenland, Nevada, or even other remote islands, such as Devon Island. But since the Houghton Mars project is public knowledge, we have a good lead here.